let us continue from what we were doing last time. Last time, if you remember, we were just starting our discussion about the timing constraints, the different types of timing constraints associated with the tasks and so on. Now, let us proceed from there. So, last time we had seen this, that the different types of tasks in a real time system can have different types of timing constraints. Based on that, we can classify them as either hard, soft or firm real time systems. So, we also had discussed this one, that in a hard real time system, the tasks have time constraints, and even if one constraint is not met, the system is assumed to have failed. And we had taken examples from robots. Timing constraint violation can crush the robot. Similarly, onboard computers, industrial control applications and so on. We had seen another category of tasks, the firm real time tasks. Here in this kind of constraints, so here again we have timing constraints associated with the tasks, and if one or a few timing constraints are missed, then the system does not fail. The results are simply ignored. The results which are produced after the deadline or after the time requirement just ignored. Examples I had said that most of the multimedia applications follow in this category. We talked about video conferencing, telemetry and satellite surveillance applications. And then we had looked at the soft real time tasks, where if the deadline is missed, then the results are not discarded like in a firm real time system, but the utility of the results go on diminishing with time, and after some time it is no more useful, it is ignored. And if the results appear within the deadline, say that the performance is good. Otherwise, we say that the system is operating in degraded performance, we do not say that it is failed. And we had said that most of the tasks that are interactive in nature, that are actually soft real time tasks. We can have another type of classification of real time tasks. Some are periodic. So, they repeat after fixed time interval. Of course, to make them repeat after fixed time interval must have a clock somewhere, a timer. It is the timer in the system which actually gives the interrupt. Based on these tasks run. The periodic interrupts from a timer make the periodic tasks run, whereas the sporadic and aperiodic, they are the events caused by the environment, no clock is involved. The sporadic tasks, as we are saying that these can occur at any time, maybe a fire condition started, do not know when it will start, but when it starts the signal will be, the event will be sensed by a sensor, the task will be generated. So, these there is no period, this can occur any time at random instance. The aperiodic tasks are somewhat similar to sporadic tasks, but with a minor difference. In the sporadic task, again the events that cause these tasks occur at random instants, but here the separation between two instances can be 0, that means two aperiodic instances tasks can, yes, they can occur at the same time and the distance between them can be 0. There can be several examples. We will actually discuss some of these situations, how they are handled in the real time operating system. One example is, let us say we have an intrusion detection system. Now, the intrusion may occur at different points and the intrusion can occur at the same time. and we need to be able to handle that. Can say that we just one intrusion will be unearthed, right. So, now let us look at the timing constraints more deeply, because the latter part of the course we will major discussion will revolve around how these different types of constraints are handled satisfactorily, what does the operating system do, what does the communication protocol do, what does the database do to meet these timing constraints. One thing that we must remember, that the timing constraint is defined with respect to some event, and the event we can conveniently think of as the instant of time. So, an event is instantaneous, but again to think of it, an event does not really occur at instant of time. For example, you press a telephone button. So, is that an instant, or keep the telephone button pressed for some time to make it work. So, it is not really an instant. If you think many events, they do not occur instantaneously. See, we assume that instantaneously, because many events can be approximated to be some specific instant of time, but it is necessary to consider that some events have duration. But again, these duration events, we can have instants of time associated with the start of the duration event and the end of the duration event. So, finally, we can say that every event can be associated with a unique time on the time scale, whatever may be the granularity of the time. It may be millisecond, nanosecond, do not bother. We can associate a unique time point with these events, and the time constraint will be with respect to that event. Now, who generates the event? The event is generated either by the system itself or by the environment, user, different activities occurring in the environment. These will cause the events. Now, let us see them further. Actually, there are two types of events that we will be concerned with. One is the stimulus event. The stimulus event is generated by the environment. So, the environment gives a stimulus to the system. For example, the temperature exceeded some value, action need to be taken. So, the temperature exceeding some value is a stimulus event to the system, and the system will recognize that and it will respond to that. So, the response events are generated by the system. Is that okay? Stimulus is by the environment and response is by the system, two distinct categories of events that we will talk of. Now, let us look at the stimulus events. Seen that these are generated by the environment to act on the system, recognized by the system, and many of these events generated by the environment are asynchronous. They do not occur according to some clock, and that is the reason many of them are aperiodic or sporadic. But this can also be periodic, because there might be a clock, and according to that it generates some events, but a vast majority of them are aperiodic. Just to give some examples of the stimulus event, just consider a telephone connected to the telephone system, and that is connects to the destination or the receiver. Now, let us say a user is trying to dial a number, he just lifts the handset and presses a number. So, lifting the handset or dialing a digit are examples of stimulus events. So, the stimulus event acts on the telephone system, where we might have computers which respond to this event. There can be also periodic stimulus events. For example, the temperature is sensed periodically according to a clock, and these you can consider as periodic stimulus events. This is the chemical plant, and large number of sensors will be placed. Temperature of different reaction chambers will be measured.
But sir, sensing is done by the system, not by the environment.
Yeah, right. So the question is that the sensing is done by the system. It is not in that sense generated by the event, because for the environment to generate the event, it basically, like intuitively we say that it pressed the button or something. But here we can think of it that these events of the system were recognized by the events of the environment were recognized by the system periodically, right. I mean, it is not according to the intuition that the environment presses something or generates an event, but the environment is proceeding on its own way, and then the system is sampling, right. And this we can think of that the system has recognized these events of the environment, something like that. So, this is an approximation. It is not really event in that sense generated by the system where it presses something or no. It just the system samples the environmental event, but we will consider this to be stimulus events.
Can we say that an interface to the system is sensing this stimulus? Not
Okay.
The system itself?
No, that he said that the interface is a part of the system, right. So, the system is actually sensing the environment. Environment is not doing anything special to generate the event, it is just proceeding on its own way, right, and we are sampling the activities of the environment, right. I mean, the system is sampling. Okay, this is, I mean, we can think of an event of the environment recognized by the system as a event generated by the system, generated by the environment. Okay. So, let us proceed. Now, the response events, these are produced by the system, and normally most of the cases we will see that the system does not produce response events simply by itself. It actually responds to some event which were generated by the environment or some stimulus events, and based on that it processes and responds to that. An example is that there might be a stimulus event that the temperature exceeded 100 degrees centigrade and has been sensed by the system. So, this is the stimulus event. With respect to that, the system generates a response event, switches off the heater. Okay. As we proceed, we will see more and more examples of stimulus events and response events. Yes, please.
Difference between periodic response events and periodic stimulus events.
Okay. See, stimulus events can be periodic.
Yeah.
I mean, most of the stimulus events are actually aperiodic, like for example, somebody pressing a switch or something. But if we talk of something being sensed periodically, that is a periodic stimulus event. But the actions, they occur with response to a stimulus event, right. So, it is I mean, hard to, or it is not very logical or very intuitive to say that a response event will also be periodic. A response event with respect to a stimulus event, we will always talk like that, right. Maybe we might have some cases where once a stimulus event occurs, periodically some actions by the system take place, but very rare. Most of the events that we will see are with respect to some stimulus event. Response event occurs with respect to some stimulus event, and it does not act by itself, right. Is that okay?
So, for every stimulus there has to be one response. So if the stimulus is
Exactly.
periodic, response has to be periodic.
Okay. See, the question here is that the response event, as we said, is with respect to a stimulus event. So, if the stimulus event is periodic, can we say that the response event is periodic? Need not be. The response, even if the stimulus event is periodic, the response event may not be periodic. It may be that sometimes actions need to be taken, sometimes it need not be taken, and it depends on the system's response time that might vary from instant to instant, right. A periodic stimulus event did not produce a periodic response event. Okay, let us now try to classify the timing constraints. The idea behind this classification is that if we know that what are the kinds of timing constraints that might arise, when we look at a problem description, we can immediately recognize that this is a time constraint. We will take up some examples later on, give a problem description and ask you to identify the timing constraints. The different types of timing constraint exist in those problems, and then we will try to model that. So, the timing constraints, as we said, are defined with respect to some events, and if it is, there are two types of timing constraints. One is performance constraint, which is a constraint imposed on the response event from the constraint is with respect to two events actually. One is the performance constraint are with respect to the stimulus event, right, and from that how much time it takes to generate the response event by the system, that is the performance of the system, right. And we can have the behavioral constraint, where given a event generated by the system, how long does the environment takes to respond to it. For example, in a telephone, once the dial tone appears after you lift a handset, the system generates the dial tone, and then how much time do you take to press the buttons or the digits to be dialed. So, that is a behavioral constraint. Okay. If you take too long to dial the digit, then the dial tone will vanish, right, and you have not really met the behavioral constraint. So, every system that we will discuss or that exist practically, they have two types of constraints there. One is defined on the response events of the system, and the other is on the environment itself, on the environmental events. So, if the environment does not meet the constraints, then some action need to be taken. For example, in a telephone set, if after the dial tone appears, even after 5 minutes you do not dial a digit, then it will produce a beeping tone, right, a idle tone or a beeping tone, right. So, that is the action that it will take, because the environment could not meet its time constraint, the behavioral constraint. This we have already seen that the performance constraint is on the response of the system. With respect to normally a stimulus event, the response event is defined, but in rare cases we will have a performance constraint from one response to another response. The behavioral constraint are imposed on the events generated by the environment. Now, again we can classify these different types of constraints, both the behavioral constraint and the performance constraint, into three types. One is a delay constraint, another is a deadline constraint, and one more is a duration constraint. Let us look at these three types of constraints and how they become applicable to these three types of events with some examples. Now, let us look at the delay constraint. This delay constraint expresses the minimum delay that need to elapse before an event should be produced. The delay constraint is the minimum delay that must elapse from one event before the other event is produced. Just see here, E1 occurs, and now for E2, for delay constraint to, let us say D is the delay constraint, then E2 should occur after D, right. T2 minus T1 must be greater than equal to D, right, it must occur after here. So, if it occurs before D, then it has violated the delay constraint, is the delay violation. E2 has occurred earlier than D and there is a delay violation. A deadline constraint expresses the maximum time that might elapse before a event is produced from another event. If E1 occurred and there is, after that E2 needs to be produced, then the maximum time that is allowed is D, it must be produced before D. Now, a duration constraint, it specifies a period of time over which a event acts. Similarly, we can have a maximum or a minimum type of duration, where the duration must be of certain minimum duration, or it may be of a maximum type, where the duration is can be up to some maximum. Now, let us look at this minimum duration constraint. So, once the duration event starts here E1, the end of the duration event must occur after the minimum time. So, this is the delay after which E2 must be produced, otherwise there will be a violation of this minimum constraint. Similarly, we can have a maximum constraint. Once a delay constraint, once a duration event starts, then the end of the duration must occur before the maximum delay for the event to satisfy the duration, maximum duration constraint. Does that appear okay? Okay, fine. Now, let us look at examples of such constraints. We will look at examples with respect to a telephone system, where we have a initiator, call initiator, who is trying to dial a number to reach out to somebody, where a ringtone will be produced, and this the number will be dialed from here. This is the example we will take. So, first let us look at the deadline example between two stimulus events. So, will it be a behavioral or a performance constraint? It will be a behavioral constraint. Why is that? Because it applies on one stimulus, right. Whenever the constraint applies on a stimulus, it will be a behavioral constraint. So, it is with respect to two stimulus events, does not matter, but finally, it is applying onto the stimulus event. So, that is the reason that it is imposed on the stimulus, that is why we are telling it as a behavioral constraint. So, let us look at an example that when a user completes dialing a digit. So, this is one event that has been produced by the environment or the user. He has completed the dialing the digit, dialing one digit. So, he wants to dial a, let us say 7 digit number or something. He has dialed one digit, let us say the 4th digit. Now, the 5th digit must be dialed within the next 5 seconds. If it delays more than 5 seconds, then he has failed the deadline constraint, missed the deadline constraint violation, and then a idle tone will be produced. The event could not be produced before 5 seconds. Is that okay? A deadline constraint example between two stimulus event. Similarly, we can have a deadline constraint with respect to one response and for a stimulus event with respect to a response event. So, this is defined on the okay, I think we have a difficulty here. So, if it is a RS deadline example, it should be a stimulus event defined with respect to a response event, but what we have written here actually is that defined on the response event from the stimulus. So, it should be SR. I think there is a mistake here. It should be SR deadline example, because it is a response event on which the constraint is defined with respect to a stimulus event. So, just change this one, this should be SR. So, since it is defined with defined on the response event, it will be a performance constraint. Is that okay? That is because it is imposed on a response. So, let us see the example. Once a dial tone appears, so this is the response. Okay, I think there is a little bit of this thing incorrect, there is confusion here. I mean, while I prepared the slide, actually RS is all right. What we should have written here is that defined on the stimulus with respect to the response, and in that case it will be what kind of constraint? It is a behavioral constraint. Just like let us look at the example, then it will become clear. See, the dial tone is produced by the system, is not it? So, this is the response produced, I mean this is the event generated by the system, and then this is the constraint on the user who must dial the first digit within 30 seconds of the dial tone appearing. Otherwise, there will be a constraint violation and the system will take some action, because the event the user could not meet the constraint of dialing within 30 seconds, the system will generate an idle tone. So, this is a RS deadline example, all right, but here what we have written here is slightly incorrect. It should have been a deadline defined on the stimulus event with respect to the response event. In that case, it will become a behavioral constraint, because it is defined on the behavior on the stimulus event. Is that okay? Okay. Now, let us look at another example, a deadline defined on two response events. So, the deadline is defined on a second response event from a fast response event. So, what kind of constraint it will be? It will be a performance constraint, is not it? Because it is acting on the constraint is defined on the response. Let us take an example. Now, the system gives a ringtone to the callee, the person whom you are calling, a ringtone is given to him, and within certain time a ring back tone must be given to the caller. He knows that the number is getting called, right, ring is appearing, and that must happen quickly enough, so that he knows that okay, ring is it is already ringing. Otherwise, what will happen now? You find that suddenly he has answered even without any ringing, right, that should not occur. You should know immediately or within a time that is not recognizable by the human, the ring back tone appears after the ring tone is produced. So, the ring back tone must be given to the caller within 2 seconds. This is a typical performance constraint on most of the telephone systems that we use, that the ring back tone, it should be produced before the humans can actually think that why it is not getting produced. So, it is within 2 seconds of the ring tone being given to the callee, the ring back tone must appear to the caller within 2 seconds. Otherwise, the system has some difficulty, some error is there in the system and the call will be terminated. So, is that okay? So, this is the example of a deadline of one response event with respect to another response event. Now, let us look at the example of a, okay, I think because the other slide was I mean mixed up, maybe this is also mixed up. So, let us see this. So, this is a deadline example of a response from the stimulus. Okay, I think if it is on the response, deadline is on the response, it will be a performance constraint and will be imposed on the performance. Now, let us look at the example. So, the receiver handset is lifted. So, this is a stimulus event, is not it? Receiver handset is lifted is by the environment or the user, and this is a stimulus event, and then the system must produce the dial tone within 2 seconds. This is on the system or on the response event. So, looks all right, is not it? So, it is a deadline example on the response event from a stimulus event, and it is a performance constraint because it is on the response event, and if the dial tone does not appear within 2 seconds, then a beeping sound is produced until the handset is replaced. So, there is a constraint violation and the system takes an action. Okay. Now, let us look at the different types of delay constraints. We had seen different types of deadline constraints between 2 system events, between 2 response events, between a system event and a response event, and between a response event and a system event. Now, let us look at delay constraints, examples of those. So, let us first look at a behavioral constraint. The behavioral constraint will be imposed on the environmental event, right. Let us look at an example. So, once the user dials a digit, must dial the digit after at least 1 second. See, in the normal handsets that we have here, we do not have the situation because it does not produce a dial digit to be dialed within certain time. Even if you act very fast enough, or let us say, okay, one thing can happen is you simultaneously press 2 buttons or something, right, or one after other quickly. So, that is a error, is not it? So, there is a delay between 2 digits which are dialed. So, if the user dialed 1 digit, the next digit dial signal must reach the system with after at least 1 second. Okay, 1 second is too much because this is not the actual value. Actually, it would have been better if I had written something like few milliseconds. Otherwise, a beeping sound is produced. So, dialed 2 digits too fast, pressed 2 buttons quickly, and the beeping sound will be produced by the system. There is a delay constraint violation, and the initiator has to terminate the call by replacing the handset and try again, right. This is a delay constraint between 2 stimulus events. Okay. We do not have examples of other delay constraint between 2 response, between a stimulus and response, and a response and stimulus. It is not that they do not exist, they exist, but for this particular example it was hard to think of those situation between 2 response and stimulus, etc. So, we just had one example of a delay constraint, that is with respect to 2 stimulus event. Now, let us look at the duration constraint example in the same PSTN system that we are discussing. As we had already discussed, a durational event acts over certain interval of time, and the duration constraint specifies the time interval over which the event should act. Should it be within certain time, after certain time, and so on. So, let us say you have a telephone system in a hotel or something. Now, if you press the button of the handset for less than 15 seconds, you just flash the button, then it connects to the local operator of the hotel, where you can request some call to be established or something, or a fax to be sent or something. Now, if you press the button for any duration between 15 to 30 seconds, then it connects to a international operator. So, the operator who handles the international calls, he will get connected if you have pressed the button between 15 to 30 seconds and possibly you want to initiate a international call. Now, if you keep the button pressed for more than 30 seconds, let us say if you release after 30 seconds, you will get a dial tone and you can dial a number. So, this is not that such systems do not exist, but this we do not use too frequently, right. In normal telephone system that we use does not occur, but this is an example of a telephone system which exists or which are meaningful in several situations.
Sir,
yes,
then
please.
can you say that the duration constant is a special case of delay?
Okay. So, the question is that whether a duration constraint is a special constraint of delay constraint. No. See, if you remember, we had said that a duration constraint is from a starting event for the duration to the end event of the duration, and there can be various types of constraints. For example, it can be a deadline constraint that the end of the duration must occur before certain time elapses, or it can be that the minimum time between the start of the duration to the end of duration must be something. So, that is a delay constraint. So, between the for a durational event we can have both delay and deadline constraints. So, we will see as we model this, it will become clear that this example that we have considered here, there are several types of events, durational events. See here one durational event 0 to 15 and another durational event 15 to 30 and then 30 to more, right. So, there are 3 durational events here, and in one event it is a deadline, right, in one case, but this durational event starts after a delay of 15. So, the start of the second duration is actually a delay of 15, appears a delay of 15. So, we will just see while modeling it, we will decompose it into several durational events, even though to us it appears like one duration that we just pressed the button and released it, but when we actually try to model it, it will become clear that there are several durational events involved, and that too several types of constraints on them, like delay constraints on the durational event, deadline constraint in the durational event. So, this is a more complex example. We will try to model it and then it will become clearer. Okay, let us proceed. So, we said that the timing constraints are basically 2 types. One is the constraint on the response of the system, which we called a performance constraint, and then the environmental events also there can be constraints on them, we call them as behavioral constraints. So, 2 main types of constraints we will be dealing with any system, and if we look closer down into the performance and behavioral constraints, we will see that the performance constraint can be either of a delay, deadline or a duration, and the delayed constraint is with respect to a for a performance event constraint, it is with respect to a response with respect to the response from a stimulus or between 2 response. So, it is defined, the performance constraint is defined on a response event, a delay constraint. So, always R is appearing at the second part here, is not it, because it is defined on the response event either with respect to a response or with respect to stimulus. Is that okay? Now, on the other hand, we can also have behavioral constraint as either delay, a deadline or a duration. Okay, I think there is a mistake here.
I have also seen SS even also.
There is a mistake here actually, because behavioral event should be always defined on a stimulus event. Actually, what I did was I just copied this and pasted here in a hurry. I should have actually changed this. This is incorrect. See here, the behavioral constraint should be defined on stimulus event. So, it should be RS type, SS type, RS and SS, the mistake here. So, the behavioral constraint can be delay, deadline or duration, but each time it will act on the stimulus event, and the stimulus event may be with respect to a response or another stimulus. Now, let us see some very basic thing is why do we need to model these constraints? Isn't it enough that we just recognize them and then we try to implement or take care of them? And how do we model them? Let us answer these questions, that why we need to model and how do we need to model these constraints. Now, let us see, first is why we need to model timing constraint. There are many reasons why we might need to model a time constraint. First of all, when we model a time constraint, we are expressing it more formally than just a few sentences appearing as a loose English sentence. We are constructing a model of it which is more precise, right. So, this can be a formal model of a constraint. We can use such a formal specification to verify a system, and also we can use such a model to automatically generate code. Actually, there are several systems being used in industries where from such specifications they can generate code. We will discuss about them as we proceed, that how from a FSM model how can the code be generated, or as not FSM, maybe some other model also, how code can be generated for a time constraint. Now, another big advantage is that if we model it, we know the intricacies in the constraint. For example, we just saw that the durational constraint, we did not really realize that there are many events in that, and there are different types of constraints appearing between those events. I mean, we just discussed few of them. When we model, we will realize that there are more constraints than what we realized. So, understanding the behavior will be more if we are able to model the timing constraints. Okay, let us proceed. So, there are, as we are saying, that there are several approaches that have been used to model time constraints. We will use a approach discussed in the IEEE Transactions and Software Engineering 1985. This is a model extends the finite state machine. Finite state machine, all of us are familiar, and this was proposed by Dasarathi, B. Dasarathi. And as I was saying that there are systems where if you model it with FSM, then it can help you generate code, and also FSM is quite intuitive. So, let us concentrate on a FSM modeling of the timing constraints. FSM we are all familiar to some extent. It is used, FSM is a very versatile tool used in many situations, and knowingly or unknowingly over various courseworks we have used FSMs to construct different types of model. But one thing we have implicitly assumed in all that models is that a state, FSM consists of many states and transitions, is not it, and the state is defined in terms of the values of some attributes in the system. For example, let us say we have a elevator as a system. The elevator can be in different states. For example, the elevator is stationary, standing, and it is maybe the elevator is in a motion up state or it is in a motion down state, right. Now, this when the system is constructed, the program or something will have some variables or attributes which will actually define the state in terms of this up, down and stationary. So, if the attribute direction is 0, possibly it is stationary, 1 is up, -1 is down, right. That can be a possibility. So, depending on some attributes, the states on any FSM are defined, think of it. Now, the convention that we will use here in our modeling is that two states are denoted S1 and S2. The transition, and the transition is annotated with the event that causes this transition, and also as the transition occurs, the action that takes place during the transition. So, if you refresh your knowledge on FSMs, you will see that there are two types of FSMs, the Mealy machines and the Moore machines. So, those things we will not go into that. We are just saying that as the transition occurs, I mean for the transition to occur, some event must occur in when the system is in state S1. For example, the system is a lift which is stationary and you press the lift up button, E1 is the lift up button, and then let us say you do some action, let us say set some motors on or something, right. So, this is a separate time, this is a real time constraint. So, we have just written timer. So, we will model these time constants in terms of some timers and some actions. So, this is the state transition, and transition we have a event, and the notation is will give a slash and write the action that take place while the transition occurs. So, the E1 is also called as the enabling event for this transition, and we can also elaborate it little bit by adding a guard here, that even if the event occurs, then some condition must get satisfied. We can add a guard condition here, but we will not do that here, just to keep the discussion simple.
So,
Yes, please.
so in this case, for one stimulus, there
Yes.
can be two responses. Like suppose we press a button,
Yes.
go to the 5th floor, then it
Exactly.
first moves up and then becomes stationary.
Exactly.
Then how do we like?
Yeah, okay. The question is that sometimes we have a event which causes a transition, but we have multiple actions occurring, right. So, in that case we will just the convention that we will use is that E1 slash action 1 comma action 2 comma action 3, that is the convention that we will use. Multiple action, multiple event, multiple responses occurring for the same event. Now, let us try to construct a model for the SS deadline constraint. So, the example that we had discussed is that after the user completes dialing a digit, so that is the response of the user, one digit is dialed, the next digit must be dialed within 5 seconds, otherwise the constraint is violated, behavioral constraint is violated, and then the system will produce an idle tone. So, the system is awaiting the first digit. This is the state, starting state for this model for this constraint, and the user presses one digit, and while this event occurs on this transition, we have a timer event set for 5 millisecond, and if the second event comes, that is I mean the event second digit dialing comes here, then we await the next digit and again set the timer to 5 millisecond, because from here also you have to do the same thing, await the next, again we will wait for the third digit and again set the timer for 5 millisecond.
Here 5 milliseconds means it is a deadline constraint. So, within 5 milliseconds second digit.
Exactly,
Then
exactly,
to-
exactly. So, the idea here is that, see, if the second event occurs before 5 millisecond passed, then this will come from this state to this state. Now, let us say the system is waiting for the next digit, and the next digit is not coming, 5 seconds have passed, then the timer will fire, right. Once the timer fires, it will come to this state, await caller on hook, and it will produce a idle tone, whatever the caller does, dials the second digit, third digit, etc. It does not, it just produces the idle tone until the user replaces the handset.
But if we want to represent delay constraint, then what?
Okay. So, we have several examples, actually all the examples that we considered we will model each of them just to make the idea clear here. So, that we can take some examples and I will ask you to construct some, identify the timing constraint and model those. So, let us see all those examples that we saw, the different types of deadline constraint, SS, RS, SR, RR, etc. Each one we will model. We will also model a duration constraint. So, the idea here is that the time constraint, the deadline constraint is actually handled by the timer. If the event occurs before the timer expires, the timer fires, then it makes the transition to a meaningful state, right, the constraint is satisfied. But if the event does not occur, that is indicated by the timer alarm firing, and then the system takes some action to handle the violation.
Wait second digit, sir.
Okay. So, yeah. Actually, the names are, I mean, we could have given better name. For example, we could have written here 1 digit instead of writing first digit. See, if we want to do the complete example here of, let us say, 10 digit telephone system. So, first digit, second digit, await second digit. Then we have another one, await third digit, await fourth digit. You are saying that we can also do like this, is it? Okay, a more intuitive one will be await second digit, third digit and so on, right. And here we could have, as you are right, we could have written here await next second digit, that would have been more meaningful. But possibly I was in two minds whether I should write here 1 digit and then next digit or something. So, that is why this has become next digit. Actually, it should have been await first digit, await second digit, that is the correct one as rightly pointed out by you. Now, yes please.
So in the previous slide,
Yes.
sir, what I think he is pointing out is that the first stage should be we are waiting for the second digit.
Yes.
So because only when
The
we
event
get
is, we have entered the first digit, sir. The event is,
Okay.
and
We are
we are awaiting the second digit.
so because
Okay.
the start of that
Okay. Yes, that is true, yes. Because the first digit has occurred and after that we are entering this state. So, in this state we will await the second digit, and once the second digit occurs we should transit out. Yes, very correct. Yes. So, that terminology we need to, or the terms that we need to correct here is that here we should be await second digit. You are very right. Yes, that is a mistake here. Now, let us look at another example, the deadline constraint defined on a stimulus event with respect to a response event. So, here as we had seen this example, once the dial tone appears, the user must dial the first digit which is in 30 seconds, otherwise the system enters the idle state. So, the dial tone appears and then it is the system is awaiting the first digit, right, and as the dial tone event occurs, timer to 30 millisecond is 30, okay, it should be 30 seconds. So, as soon dial tone is set, timer is set to 30 seconds, and if the dial tone, I am sorry, there is again a mistake here, first digit, right, if there is a first digit occurring here, there is a mistake here. So, I will just correct these mistakes and possibly first digit. Dial tone has appeared and it was awaiting the first digit, and the first digit has occurred, then it next digit, right.
but
And if the first digit does not appear and the dial tone has appeared more than 30 seconds earlier, then the timer alarm set here will fire and system will produce a beeping sound, and until the caller replaces the handset on the telephone set. So, we will look at these examples for each the modeling of each of the types of constraint examples we had discussed, and then we will just set a example problem for you to see that whether you are able to do that from here, because as we are saying that modeling the timing constraints is important from various points of view. There are many uses, right. So, let us stop here, we will meet in the next class.